students, how are you? Today we are here to discuss about class 10th science, a numerical problem based on electricity. See students, electricity is very important chapter in class 10 science. Now let's have a look of the problem. In this problem it has been given that in a household the schematic diagram has been shown like this. Right? Now you see here this is the mains from where a 220 voltage has been supplied to all the rooms. How many rooms are here? Room number 1, room number 2, room number 3 and a lobby. Right? And the respective wattage of load has been given as 125 watt, 150 watt, 120 watt. Correct? And the lobby, the load has been given as 170 watt. Right? Now, this is the data that has been given. And what do we have to find? We have to find the currents in each room in the lobby. Right? Means room number 1, room number 2, room number 3. What are the currents? And what is the current in the lobby itself? Right? Now, the second part is find out the resistive loads in each room and the lobby. Correct? And third part is what is the net current drawn through the mains? Means what is the current which is coming from the mains? Right? And the third part, if the rate of electricity has been given, then how much will be the bill of electricity for a month if all loads are active for continuously 8 hours daily. Right? Now let's just start solving the first part of the question. Find out the currents in each room and in the lobby. Means we need to find out the current here, here, here and here. Right? Now, before solving this part, we need to understand and we need to recall two formulas. P is equal to VI, power loss, is equal to voltage and current. Right? So, P is equal to VI. From this formula, what do we can find? I is equal to P by V. Correct? Now, in our household, what happens? All rooms and the equipments, they are connected in parallel combination. Why parallel? Because all instruments, they work on 220 voltage. Now, if the voltage goes beyond 220 volt, what will happen? There will be a chance of burning. And if the voltage goes lower than 220 volt, so the equipment will not work properly. Right? So that is the reason that 220 volt, which is from the mains, and as the rooms are in parallel combination, so this entire 220 volt will be supplied to the respective rooms. Correct? Means here the voltage is 220 volt exactly. So in this formula, if you see, V has been given, power has already been given, so we can find out the current easily. So I1 will be equal to P is equal to VI, just apply the formula, you will get I1 is equal to P by V, right? This is P1. Now you replace the value. P1 has been given as 125 watt upon 220. So you can find out the value of I1. Similarly, for I2, you need to write down I2 is equal to again P2 upon V, right? Which is equal to 150 upon 220. You can find out the value of this I2. Then I3 again. What is the value of P2? P3 150 220, we can find out. And IL, the current in the lobby. So IL will be power loss in lobby upon voltage. Voltage is 220. Finally, 170 upon 220. Hence, we can find out the respective currents in all the rooms and lobby. Correct? Now, second part, find out the resistive loads in each room and the lobby. Now, we need to find out the resistive load means R1, R2, R3 and RL. Right? Now, how to find out that? For R1, we have V upon I1. Right? V is equal to IR. This is Ohm's law. V is voltage. Voltage is equal to current in that circuit, and then the resistance, which is the load, resistive load, right? So just apply this formula. If we have to find out R is equal to, from this formula, R gives us, R is given by V upon I, right? So R1 is equal to V upon I1. Now we know that voltage on each room and the lobby are 220 voltage, right? So V is equal to 220 upon I1. I1 we have already calculated, 125 upon 220. So finally 125 upon 220, we can find out the value of R1. Then similarly we can find out the value of R2. Again 220 into 220 upon, what is the value of I1? Sorry, what is the value of I2? I2 is again P2 upon V. So we can find out 150, right? Then R3, R3 is equal to again V upon I3, 120 into 2. We find out the value. And then RL is equal to, again apply the formula, 220 upon, what is the current, into 220, right? So hence we have find out the values of R1, R2, R3 and RL. Now C part, it is that what is the net current drawn through the mains. What is the net current drawn through the mains? Correct? Now here we can see net current is basically I, which is equal to I1 plus I2 plus I3 plus IL. I is equal to I1 plus I2 plus I3 plus IL. Correct? Now as we know that V is equal to IR, so the net current I net can be calculated by V upon R net, right? Or else what we can say, total voltage is 220 volt on R net. Now value of R net can be calculated from R1, R2 and R3, right? You need to just write down these voltages in parallel combination, because R net is basically in parallel combination. So you can write down 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus 1 upon R1. And as we have all found the values of these four resistors, we can find out the R net from this formula, and just by replacing this you can get the value of net current withdrawn. Right? Now next part it says that if the rate of electricity is 5 rupees per unit, how much will be the bill of electricity for a month if all loads are active for continuously 8 hours? Right? Means we need to find out the total active load on daily basis, and then we can find out the bill of electricity, right, for the whole month. Now how this part can be solved? So for this, let's add all these loads. That what is the total consumption of this house? So 125 watt, 150 watt, 120 watt, and then 170 watt. Right? This is 170 watt. Now on adding these values, what we can get? We can get total 565 watt. Correct? 125 watt of room number 1, 150 watt of room number 2, 120 watt of room number 3, and the lobby 170 watt. So finally, on adding all these loads in wattage, we get the total load. Correct? Now this is in watt. Correct? Now it has been said that all the loads are active for continuously 8 hours. Right? So first of all, this 565 watt can be written as 5.565 kilowatt. Then what is the kilowatt hour? kWh. Into 8 hours, that is kWh. Right? Now once you multiply this, this is your value in kWh. Now 1 kWh is equal to 1 unit. Finally you have 0.565 into 8 kWh is equal to 0.565 into 8 unit. Right? Now this is on daily basis, means total this unit of this much of unit of electricity is consumed on daily basis. So for 30 days it will be multiplied with 30 into 8 into 0.565. How much you are getting? You will be getting, this is 5 to 15, right? 18, 19, 1, 15, then again 16. Right? So you will be getting 1.6 into 8. Right? So finally you are getting 8 5 to 40 and 72. And 30. Total 13.56 unit. 13.56 unit per month. Right? Now the rate of electricity has been given as 5 rupees per unit. So monthly bill, what is the bill, is equal to 5 into 13.56 rupees, right? So you are getting 67.8 rupees, right? This is your monthly bill. So hope you must have understood this problem very well. If you have any doubt, you can pause the video and again rewind and you can understand it very well. And still if you have any doubt, you can write a comment and you can get your query resolved by me. Till then, thanks a lot, and next time get ready for a new series. Thank you.